Hey everybody, since my channel normally deals with cars, you're probably wondering why I got a big pile of parts laying around me here. Today's topic is computers, desktop computers in particular. I know I usually work on cars and I work on boats, but I get into a lot of other things. And something I've been doing for well over 20 years now is I build my own desktop computers. And I know many of you probably, work off of a phone or a tablet or a laptop, which, I have a nice one of those too. But desktop computers are pretty handy for certain things, at least in my world. Since I'm running a channel here, a YouTube channel, I need to process a lot of video. And kind of what's happened is that my current machine, which is now like 12 years old, it was kind of state-of-the-art 12 years ago, but it's having trouble keeping up, and it's taken me a lot of time to process video, especially when it gets more complicated and I do more editing. So I'm looking for a chance to speed things up. I'm going to do this in two parts. The first one is I'm going to explain to you what I decided to buy for a build, and then I'm going to go through assembling one. If you're a car guy and not an electronics guy, the thing is, that 20 years ago, 20, 30 years ago, Windows operating systems sometimes were kind of complicated. Well, Windows operating systems are complicated, but they've gotten better for the do-it-yourselfer, I'll call it. There were a lot of things you used to have to tweak to make a build work, and it's still not simple, but it actually works pretty well. You can usually assemble the parts, install the operating system off of a flash drive or off of a disk if you got CDs or DVDs, and fire it up, and Windows will find all your parts and install all the drivers and even download drivers that it needs and make things work. And so that's made life a whole lot easier. So my point today is that I'm building a desktop computer. It's really a gaming computer. A gaming computer and the power that goes with it is great for editing video and pictures and the stuff that I really want to do. That's, its target. And so I'm going to end up with a gaming video card and a gaming type processor, and this will be a powerful machine. Most of the specs will be targeted toward doing gaming. And I'll dig in here and show you that a little bit. Why would you build your own in the first place? I mean, I can go down to Costco and I can buy a desktop machine that's already outfitted, or I can go to Dell, or there are a number of different companies. What happened was, in the beginnings of things, I'll say in the 90s and early 2000s, there were a lot of places like Gateway and Dell, and they sold machines that you could customize. And as time went on, the numbers of options got smaller. You had a lot of choices yet. Certain things, like this is going to be a photo processing machine. I need extra hard drives. And most of the cases that you buy, if you're lucky, there will be room for a second hard drive. But I started building my own because I wanted bays. I wanted 3 or 4 bays to be able to put additional hard drives in, to store data, to do photo processing, which the video editing a lot of times needed a separate hard drive from the one that the operating system was on. They've gotten better, but there were times where you needed those things separated, or the video software would crash in some cases. So anyway, the main one was for space. The second one is, with a desktop, is you can get a lot more power than you can in a laptop or in a tablet. Now, my laptop's got a lot of power. This one's a couple of years old now. And what I bought was a gaming laptop, and it's pretty good, but if you want to do something where you're doing a lot of video editing and a lot of photos, and you start using a lot of space, this machine has a terabyte drive in it, and it actually, I spec'd it out, it has a second drive that's also a terabyte. But my current video desktop I've got it's an 8 terabyte drive, just storing up all the videos I've processed, a couple of hundred that I've processed for the channel. I like that flexibility. I also ran into trouble where some of the manufacturers were, I'm going to call installing what I would call custom cards. You know, their video card or their network adapter card and things were tailored to their build, and they weren't the same as a retail card. So when you'd get 3 or 4 years and then they'd stop supporting the computer, and you couldn't get drivers because their card was special. So by building your own, you know, I can go back to the manufacturer of a video card and I can get support for that for years out, because I'm buying a retail product and they support the retail product for a longer period of time. I actually am at the point where I'm probably going to build 2 computers. This one is the one I'm going to call the power machine, and then I have a second one in the house that I use as a, you know, we use for general purposes. So what do you need to build a computer? Well, you got to have a motherboard, you need a processor, in most cases you need a video card, but there are some exceptions to that. You need a hard drive, and hard drives look different now than they used to look. I mean, this is a picture of a solid state hard drive, and in my new machine I'll have a combination, because the big video editing, video storage goes on an old conventional hard drive, but the operating system will be running on one of these guys. You need memory, power supply, cooling, and this is, because I'm building a big machine, this is special cooling. There's the memory chips and a case. And you'd think some of this stuff would be simple, like a case. Oh, that's like falling off a log, right? Well, it depends on what you want in a case. You know, how many hard drive bays do you want? How big is it? How big is your motherboard? You know, what are the features? What's the cooling? In this particular machine, I'm going to do something I haven't done before, and that is, this one that's in the middle here that's cooling is actually a liquid cooler with a radiator. And you need to buy the right case to be able to fit the radiator in it. For a daily machine, I wouldn't do that, but for this one, I'm going to go a little more state-of-the-art than I used to. Let me add to that. Microsoft, this last time when they went to Windows 11, picked an arbitrary point. They probably have a good technical reason, but they picked an arbitrary point and said they aren't going to support microprocessors, Intel and AMD microprocessors, older than a certain point. This machine that I've got that's 10 years old, 12 years old, I can't put Windows 11 on it. It won't work. My other machine that I said I might upgrade, again, it's like 14 or 15 years old. It still performs adequately for doing what we need to do on a daily basis. But when Windows 11 becomes the only choice in a year, I forget the exact out date for Windows 10, but it's approaching. You need to be prepared for what are you going to do, and so I'm starting to prepare. Normally when I go buy these parts, I don't buy the latest and greatest. I buy like one generation back, because they're better from a price standpoint. But not knowing where Microsoft's going on the next time they snap the chalk line, I figured on this one I'm going to spend a little bit more money and be at the front edge. Now, first decision for me for power machine is processors. And there's some general principles with processors. More is better. More is better. Back in the olden days, this is the processor out of one of the first computers I built. It's an AMD, and it's a single core processor. Now you can go all the way up to 12, 15 cores, and then threads. Intel started it, but it used to be you had a single core with a single thread, and if you were doing a bunch of different tasks, your operating system and your processor had to split them up and share time. So if you had, I'll just say you had a web page up and you got a virus scanner running, the virus scanner would run for a little while, and then it would have to stop, and then they'd run your web page, it would have to stop, and then it'd go back and run the virus scanner, and it would be bouncing back and forth between tasks. And your processor does this all day long. But the more cores you have, well, if you had a single core with 2 threads, you could assign each one to a separate thread, and they would kind of run in parallel on the same processor, in the same core. Well, now you got multi-cores, and each one of them's got 2 threads, and so you can get a whole lot more capability to do multiple things at the same time, is what it comes down to. And I'm kind of broad brushing. I mean, if you got down into computer science, there's some technical things that are more detailed than that. But from a broad point of view, that's what you're looking at. Clock speed, you'll see, megahertz, how fast is the clock? Faster's better, right? Well, why is that? Well, when a computer goes through and executes instructions, again, they're finding ways to do better than that. But in the traditional processor in a single core back in the day, right, you're running a bunch of computer instructions in a sequence. And the processor is doing a lot of things in parallel, but they all have to be done in a time sequence. And so when the clock turns on, it goes and calculates through the processor. And then the clock turns off, and things are kind of moved to their next state, and then the clock turns on and it makes the next calculation. And so it's clicking through, but it uses the clock as a synchronizer. So the more times you synchronize, the faster things go, the faster, more operations per second that you can get. The downside is that the more cores you have, the more threads you have, and the faster the clock goes, the more power you consume. And it goes up really fast when you get to the higher end processors. And then design generations, every time they come out with a new design, they wouldn't come out with it unless it was better than the old one. And so they keep moving forward. And the better ones are usually the latest. And then price. Everything gets more expensive as you go faster, more cores. Everything you ask for, the company's going to willingly sell you at a higher price. So you have to do a cost-benefit balance and figure out what you want to have. So there are a number of resources out on the web that I use. One of them I like to use is this Passmark software. They have, Passmark runs a bunch of standard benchmarks that they have, and benchmarks aren't perfect. It's just a standardized test that everybody can run their part against and see how it stacks up. Now, sometimes manufacturers will fudge a little bit and they'll design their part to run the benchmark, and in real life it might not do the same. I'm not going to kind of hit that today, but it's just something to keep in the back of your mind. Benchmarks are useful, but they're not all in all for everything. So anyway, this chart is basically the latest high-end processors that are available for the consumer market. And if you went all the way to top to the best one, this AMD Threadripper, they want $2,000 for that. But it's fast. And so you can come down here and you got to make, I could have done some Intels. There's a number of Intels in here that do a little better on the benchmarks. But I settled on, my last one was an Intel i7. The one I'm replacing is an Intel i7. I decided this time I'm going to go back to AMD because in general they had some things I liked better, and some of it was power performance. How much power do these things draw, and how much heat do you want to dissipate? So the one in the red circle, the 7900X, is Ryzen 9. That's this guy right here, is what I purchased. Now, if I go into this red circle on the bottom here, which is a Ryzen 5 3600, I have another computer that I have built. It's great for web browsing. It's a pretty good general purpose machine. If you look at that one today, its rating is a little under 18,000 CPU marks, and the one I'm looking at is at 52,000. So it's like, what, it's about 3 times faster roughly, or it can process things about 3 times faster, just to get a sense of it. Then if you do price performance, this is a separate one in the benchmarks, which is a comparison based on how much performance do you get for the dollar that you spent. You know, this one says it was $409, and so it's actually one of the better price performance. The Intels are pretty close, but we'll get into that. And actually, this one I managed to get on a good day, and I got it for like 380 something. It was on sale. And if you go to AMD's site for the basic specs, you know, what are you getting out of this? Well, it's 12 cores, it's 24 threads. You get 2 threads to a core on this one. Its maximum boost for a single thread, if you're just doing one thing and nothing else, it can go up to 5.6 gigahertz, which is pretty darn good. And its base is 4.7, which means it draws up to 170 watts. So you can see that, you know, compared to, there's like the 7900X and then there's a 7900, and by buying the X, it bumps up the speed a little bit, bumps up the base clock a bunch, and it adds 100 watts to the power consumption. And actually something I learned in this is this TDP is like total power dissipation. And even though they publish that at 170 watts, they'll let it run above that at some points, and I understand it goes 220 or 230 maybe on the upper end. So you got to be careful when you get your power supply. One of the things about when you're crunching video is that it's more than just your processor. Your video card plays a part in it. Many of the video processing software use the power of your video card, your GPU, to help with your CPU. So I'm kind of looking at the benchmarks and going, okay, you know, one is, how does the CPU do on video processing, and then how strong a video card do you get? And here's the one where, you know, they'll tell you that it pulls 170, but in reality they'll let it go up to 230 watts. Back earlier to my comments about Intel and why I kind of leaned away from some of theirs, is if you get into some of theirs, they're up to 250, they're another 20-30 watts higher, and it started to get to be a break point of how much power were you going to draw on this thing, and I kind of drew my line at this one. Because the more power you dissipate, the more heat, the bigger the cooler, the more heat you have to get out of your computer case. So that was the one, and see, they had a promo code, and so I got it for $380, which wasn't a bad price tag. One of the things, if you're going to go build one of these things, is, you know, you go to the manufacturer's site and look up their technical information, and AMD is actually pretty good at providing spec sheets and so forth that you can find for I'll call it for the hobbyist. Now, one trick on these latest AMD ones, you have to watch down here in the memory speeds. It runs, the fastest memory can only run 2 sticks. If you run 4, it slows down, so it's like 5200 speed, and it drops to 3600 if you put in 4 sticks, which we'll talk about in a minute when I get through to memory. So this is just an example of AMD's page where you can go in and you can select, you can see what compatible memory is, you can see what they recommend for cooling, and what they recommend for storage. Here's an example of the memory list. Now, I was having trouble finding memory, and I ended up going to the memory supplier, and they created a customized list by processor and motherboard, and so I went in and verified my memory that way. Here's a list of all their coolers, and when I got down to here, these are all supplied. This Wraith cooler is one that's bundled with the processor when you buy it. So if you bought the lower power processor, they'll provide you a cooler. I needed more because I bought the high-end one, and I've settled on these Be Quiet Silent Loop 2s. I ended up buying the 360, which is the big honker. It's an experiment. This is something new. So there's the 2-slot version, and there's the 3-slot version, and it's got 3 fans on it, and my case is supposed to be able to handle it. So I said, okay, we'll go a little bit further and we'll see how that works. Try to give this processor a little more margin. Then you want to go buy a motherboard, and you want to check the motherboard to make sure that they'll support the processor. Now, motherboards, I'll show you some pictures in a minute, but I've been buying from Gigabyte. There are a lot of companies making motherboards, and this is a Gigabyte board, socket AM5. AM5 is the latest for an AMD. I have others. The one I mentioned that I already have is an AM4, but AM5 is their latest socket, and that's what you need to run to this latest processor. So I spent a little more money to get the latest, but I'm trying to future-proof a little bit. And when you go into Gigabyte's website for this board and for its revision level, you'll find the BIOS, which is the basic program that the motherboard needs to run. They'll update it based on the processors. So when the board was brought out, version version 1 will run just about every processor, except when you get to the latest one. See, this 8000 version one right here needs a version 20. So if they find a problem with the motherboard, a bug of some sort, they'll issue a new BIOS version that you can flash update the board with. So this was the board that I bought. It's a $200 board. It's an AM5. In order to do that, it's got an AMD chip called a B650. It's an ATX, which is the size of the board. It's a full-size board. It takes DDR5 memory. It does M.2 solid-state hard drives. It's got Wi-Fi built into it. It has Type-C USB in it. High-speed LAN, 2.5 gigabyte, or gigabit. Q-Flash is their means of updating the BIOS. And the easy latch is just how you latch the hard drives in. This is what the board looks like. I've purchased now, I bought several, in the beginning I bought a couple different kinds of boards. And over time I settled on this. Some of it comes out of my hybrid and electric car background. I just looked at Gigabyte, and they have a term that their sales point is, they call it ultra durable. And they tend to use good heavy copper in their traces. They use very high quality capacitors, because back in the day when I started doing this, a lot of motherboards would die because after a year or two, because the capacitors would age out and they would pop and the board would go dead. So in any case, I have now built, I think I'm probably up to 14 or so, 12 or 14 different builds, all with Gigabyte boards. And I only have one out of those that failed me. I had one that, it didn't die completely, but it started having random reboot problems. And after doing a lot of diagnostics, I replaced the board just because, out of suspicion, and that cured it. Never had a problem after that. But out of a dozen boards, and even that was, the board had been running 24/7 for 3 years before I had trouble with it. So I've just, from my standpoint, the quality has been pretty darn good. I know there are others out there. I'm not throwing shade, I'll call it, at anybody else. I've just grown to have some confidence in it. So What's interesting on this one is that this is a gaming board, and so they expect it to go in a high-powered unit, and it has a lot of heat sinking to take heat out of the components and spread it into the air, and then you just need fans to move the air out of a case, right? And in this one, underneath these covers here and here, you put your hard drives, which are, you know, little solid state modules that are much smaller. And so today you mount those right on the board so that the distance from the processor that goes here over to those modules is very short, and it improves the speed. And then by buying a full-size ATX board, you still get a couple of expansion slots over here if you need to add some features. They use PCI-Express. That slot's for a the video card, and then these two are for other, you know, if you needed some more USB ports or something, you could buy an expansion card that would plug in there that you could expand further. These things help you understand, you know, if you look at their designs, you know, what kind of plugs are on here. This is what the back panel looks like. So this one's got 4 USB 2 ports, 4 USB 3.2 ports. Here's one for the C. Here's some USB type 3.2 Gen 2s. And then in addition to things, there are headers, there are plugs on the board. They call them headers, but there are plugs on the board for more expansion. Like this one that says front USB type C. If your case has a USB-C port in it, you can plug a cord into here and pick it up and feed that to the front of your case. Again, these are additional options that you wouldn't get when you buy a store-bought case, because now you can add on. So now we'll get to video cards. It was like, what kind of a video card am I going to get? Well, this happens to be, this is February. And they just had a bunch of consumer electronics type shows, and the companies have released a bunch of new stuff. And so when they do that, the last generation gets less expensive. Video cards can be really, really, really expensive. These top of the line ones, you know, some of them are $1,200, $1,500, close to $2,000 for a video card. And that's way out of my budget, and I don't need that much, right? But the question was, you know, some of what I do in video processing, I've got some things, like my dash cam, that give me data in 4K resolution. And so I wanted to go a little bit further in case I get into things where I want the higher resolution video more than the 1080. And I found a good deal, relatively speaking, on an RTX 4070, because they just came out with a 4070 Super. Well, the Super's better, there's no doubt about that, but it was about $100 cheaper to buy last year's model. So I bought an ASUS 4070. It's actually one that they call the overclocked edition, so it gives a little bit better performance than what's shown on this chart, because the factory has kind of bumped it up a little bit. So it's up in this range. It was a little over $500 card. Now, in relative terms, we're going to talk about my old machine and its capability for a minute. This circle down here is an R9 390. The card I have in my old machine is actually an R9 290 below this. And so in 12 years we've gone from, you know, that card would have probably run 10 frames per second. It would have been all the way down here, and now instead of 10 frames per second, I'm going to have a card that would do 120. So, you know, it's gone, you know, the card is 10 times more capable than what I'm using to edit video today. Frankly, when I get done with this machine, I think it's probably going to be overkill, but knowing how technology progresses, you know, my goal is to have a machine that will run another 10 years and still be functional and usable. Hopefully I'm still around in another 10 years, Lord willing. So again, I used Newegg. This is the card I bought. It was $10 off, and then they were offering some combo deals, so I did okay. Memory. Now memory is the next one. You want fast memory. You need to go back to the motherboard supplier or to a memory supplier and make sure that the memory you choose is compatible with your motherboard. If your memory isn't compatible with your motherboard and your processor, it won't work. Now, like, this is another place where I paid extra. I bought 64 gigabytes of memory. It's 2 sticks, DDR5 6000, which is fast, pretty darn fast. It's faster than the rating for the processor. But knowing how these things work, I may very well be able to achieve that speed. My current machine has 32 gig. One of the things I've learned when I built machines before is buy the memory up front that you think you're going to need, because you spend on this, and then 2 years down the road you decide you want more, and you throw away the old ones and buy new ones, and it's a waste. So I went out on a limb. I spent $200 on the latest memory and twice as much as I have today, and hopefully that'll keep me going for a while. Hard drives. This is what the new hard drives look like. They're these sticks that mount right on the motherboard, like this. And I bought 2 of them. And you're going to go, Dan, what'd you buy 2 of them for? Well, this is me. Most people would buy 1. There's a function called RAID, R-A-I-D, it's an acronym, for redundant array of independent drives or disks. And there's a RAID 1, and RAID 1 is what they call mirroring. So you basically put 2 drives in your motherboard and you set up RAID 1, and it mirrors the 2. It writes the same thing to both of them. Now you go, why do you do that? It's kind of a waste. Well, when I first started building computers, I had a hard drive die. In fact, it died within the first 2 weeks of me building the machine. And I lost a bunch of data. Even though I had most of it backed up, but not everything. And I had just spent a bunch of time building the machine, loading all the software, and that's when I started doing RAID. So, and it's bailed me out a bunch of times, especially as machines age. So everything on your hard drive goes to 2 drives. Now, I still back up my data probably every month or so. But, because you could lose, in other words, you could have both drives die at the same time, or the motherboard could die in such a way that you corrupted both drives. But normally what happens is, you write all the data to one, it gets copied to the other, so the software is constantly matching the 2 drives. So if one of these dies, the machine will keep running. I can go get a new drive, replace this one, and be back running. And I've used that a fair number of times. It's pretty handy. So I paid $160 extra to get a second drive. From a speed standpoint, it can slow down the system a little bit. There's a lot of, I've seen test data though that says that it typically it can read from both drives, so it reads pretty fast. Writing to 2 takes a little bit longer, but these solid state drives are so fast, I'm not worried about it. So RAID, very, very good system. Then the case. Now, I'll tell you, this looks like it's backwards, but I actually looked for the case before I spec'd all the other parts. I mean, I sort of knew what processor I wanted. I was pretty close, but it took me quite a while to find a case and look at the airflow in the case, look at whether it could mount the radiator, where are the buttons, where are the ports, what ports does it have, you know, how many fans do you get, where do you put the power supply. All of these things, before you order the first part, you kind of got to go look down the list and check them all out. Finally, power supplies. Now, Seasonic, this particular one has a 10-year warranty on it. It's a pretty doggone good power supply. In the past, I've also used ones called ANTEC, A-N-T-E-C. I've bought ANTEC cases and ANTEC power supplies, and they've never failed me either. My ANTEC power supplies were really reliable. And this is another one where we talk about capacitors in the electronics. A lot of power supplies die early or died early because companies were using cheap capacitors. And the better power supply manufacturers use high-grade parts that they can stand behind and warranty for a long time. When you get done, now I've never built a computer that I needed an 800-watt power supply before. But if you go to the power supply manufacturers and some of the other sites like the Motherboard, they'll have estimators for how much power you need to run a machine. And you can go in with checkboxes and go, I got one of these processors, I have hard drives like this, I have a motherboard like this, I have a video card like this, and it'll go add it all up and say, oh, you better have a power supply at least this large. In my case, it said I needed around 700 to 750. And I would have bought a 750, but they were out of stock, so I bumped up and bought an 850. The only downside, you don't want to go crazy too big because it's an efficiency thing. And these, what they call an 80 plus gold, gold is, all of them say 80 plus, and then they've got like bronze and silver and gold and platinum. Basically those ratings are how efficient it is. So this 80 plus is like 90% efficient in its mid-band. And at the very, very low end, its efficiency falls off down to like 87 or something. So it's always above 80%, but the higher the silver, gold, platinum thing, the higher that is, the more efficiency you get across the band above 80. And you can go look those up online. Go ask the question. They'll show you. Seasonic, they show you the power curves. And so this one is, I think it's like 87% efficient at 20% load. You kind of want to watch, what's the efficiency down at the lower end, where if you're running it all day long and you're not processing video and it's, say, idling, you still want it to be pretty efficient down at the bottom end. Also, you want to look at the connectors that you have and make sure that your motherboard and your video card power connectors are included in the selection of parts that come with your power supply. Make sure it's compatible, because there are sometimes different plugs required for different accessories. And I'll say finally on power supplies, this one is what's called full modular, which means you don't need all the cords that they provide. You only use the ones you need, as opposed to having every one of those cords hardwired into the power supply, so that if you're not using them, you need to find some place to tuck them and store them when you're all finished. Now on the subject of cooling, I talked about using a radiator and water cooling. I'm only doing that on a high-end machine. On a normal day, a standard, I'll say 50, 60 watt processor can just use one of these aluminum heat sinks with a fan on it. It's pretty small, air-cooled. Every computer I've built starts with one of these, and if you get really high into the power, then you can end up with one of these tower variety ones that has a fan on it and a big aluminum radiator. And these are fans on some of my older rigs. And honestly, on this rig, I planned to use something of this style, only newer, of course. But going back to manufacturer's website, AMD said for this one, at the power that it dissipates, buy a water cooler. That's our recommendation. So I say it's kind of an experiment, but this is my pile of parts. That's why I went the way I went. I'm going to dig in here shortly and start putting this thing together.